Hello, my listeners. I go by the name Gifty Darko, and today on this lesson, we are going to be talking about memory cache mapping techniques. In this lesson, we are going to explore the fundamental strategies that optimize data retrieval in computer systems. What is a cache? A cache is a high-speed memory component that stores copies of data from frequently accessed main memory locations. It acts as a buffer between the CPU and the main memory. So as we know, there are some websites there are some places on our website that we visit mostly. So these places that we visit mostly are being stored in the cache memory so that it's going to be easy for accessibility when it's needed. Performance enhancement. Its primary purpose is to reduce the average time required to access data, significantly improving the overall performance and responsiveness of the computer system. The necessity of cache mapping. The effectiveness of a cache hinges on its ability to efficiently store and retrieve data. This is where cache mapping techniques become crucial. So one, how all this is trying to say is that how does a cache mapping technique helps or how is it important? One, it helps in the storage challenge. How does the cache decide where to place a block of data transferred from the main memory? This decision directly impacts performance. So with this, through the cache mapping techniques, the cache knows where to store the data being taken from the main memory. 2. Accessibility challenge. Once stored, how can the cache quickly locate and retrieve the required data block when the CPU requests it? So to make it easier to access the data when it's being required. That's why it's needed for us to implement this cache mapping techniques. 3. Mapping solution. Cache mapping techniques provide the rules and algorithm to manage this storage and retrieval challenges, ensuring efficient cache operation. So moving on, I'm going to be touching on the types of memory cache mapping techniques. We have the three primary strategies used to map main memory blocks to cache locations. Each has its distinct advantages and disadvantages, influencing system design and performance. So one, we have the direct mapped cache. Each main memory block has one dedicated location in the cache. It's simple but prone to conflicts. 2. Fully associative cache. Any main memory block can go to any cache location, offers flexibility but is complex and costly. 3. Set associative cache. A hybrid approach where each block can map to a specific set of location within the cache balances flexibility and complexity. So with a set associative cache, it has features of the direct mapped cache and also fully associative cache. So it's a kind of mixture of both mapping techniques. But with this particular type of technique, it's the cache is being divided into sets. So here's the case that the data is being stored in anywhere or any slot available in a specific set. So moving on, I'm going to further explain the direct mapped cache and the fully associative cache in my next slides. So with a direct mapped cache, in a direct mapped cache, each block of data from main memory has one or only one possible location within the cache. This mapping is determined by a simple formula involving the memory address. With this particular type of mapping technique, it has one particular location that the block of data is being stored inside. And here are the advantages and disadvantages. Starting with the advantages, it's simpler to implement. The direct mapping rule reduces the complexity of hardware logic required for placement and lookup. Also, it has a fast lookup. The fixed location for each block allows for rapid determination of where to look for data, leading to the quick hit times. So it means it's easier to access the data or it's easier to look for the data. The disadvantage is high potential for conflict misses. If frequently used data blocks map to the same cache location, they will repeatedly evict each other, even if other cache even if other cache lines are empty. This is known as trashing. Underutilization is my second point for the disadvantages. Some cache lines might remain empty while others experience high contention, leading to inefficient cache utilization. Moving on to talking about the fully associative cache, which is my last slide. In a fully associative cache, any block from the main memory can be placed in any available location within the cache. There are no restrictions on where a block can reside. So with this particular cache, any available slot inside the cache can be used to store the block of data. The advantages are it's very flexible, offers a great flexibility in block placement, allowing optimal utilization of cache space because since it doesn't go with any particular restriction, but any empty slot can be used, it is very flexible. It has a low conflict misses. Since a block can go anywhere, the chance of two frequently used blocks conflicting for the same spot is minimized. Also, it has a high cache hit rate due to the minimal conflict misses. Fully associative cache typically achieve the highest hit rates among the three types. Also, the disadvantage of the fully associative cache are complex to implement. It requires complex security to search all cache lines simultaneously for a match. Expensive to implement. The complexity and specialized hardware most make it the most costly cache mapping the technique. Slower lookup time for large cache. While parallel search is fast for small caches, the complexity increases significantly with cache size, potentially impacting the lookup speed. And this is where I end my lesson. Thank you.